The names of acids are usually considered to be derived from the names of the anions that can be thought to be their parents. That is to say, if we have an acid HX, for example, we can think of that acid as being made up of H plus X minus. So the name of the acid is related to the name of the anion. Now, in a case where the anion is actually a polyatomic anion, the name involves the name is derived from the name of the anion in the following way. If the anion has an ATE ending, like nitrate or chlorate or sulfate, that is changed to IC. So the name of the acid would be the root of the polyatomic anion name. So, for example, in this case, the IC ending is put in place of ATE. So, chloric acid, the name chloric acid, means that it's derived from the chlorate anion, which is ClO3 minus. So we can think of chloric acid as being derived from ClO3 minus plus H plus, and so the formula would be HClO3 for chloric acid. Now, in a case where we have a binary acid, just two elements present, the procedure involves the prefix hydro. So it would be hydro plus the root name of the acid plus IC in this case plus acid. If we apply this to HF, you can think of HF as being made from H plus and F minus. And of course this is the fluoride ion. So the root of the fluoride ion is FlUOR. So the name of HF would be hydro fluoric acid, hydrofluoric acid. And if this were chlorine, HCl would be hydrochloric acid, if it were Br, hydrobromic acid, and so forth. So that's how we handle the name from the formula of binary acids like this. Acetic acid is a case like chloric acid, where we can think of it as being derived from an oxo anion. In this case, the anion is the acetate ion, which is a little different. It's an organic anion. It's the acetate ion, and it is C2H3O2 with a single minus. It's one of the ions that we ask you to learn from the tables. So acetic acid can be thought to be made up of this anion plus the hydrogen ion. So this would be HC2H3O2, or if you wish, you can write it as CH3COOH. Same thing. Sulfurous acid has an OUS ending. And an OUS ending is derived from an anion that has an ITE ending. So in this case it would be sulfite. The root sulf plus ITE for the SO3 2 minus ion would translate then into sulfurous acid when we combine it with two protons. The overall formula would be H2SO3 for sulfurous acid. So we get the formula from figuring out what the anion would have to be to produce this name. So Acids with an OUS ending on the first part of their name come from anions with an ITE ending on their names. If we look at the last one here, HBRO, this one is derived from the anion BRO minus. Okay, you can think of it as being made up of BRO minus and H plus. BRO minus is the hypobromite ion, and therefore this acid is hypobromous acid. The names of the anions are what gives us the name of the acid. ITE goes to OUS.